Okay, looking at the carbon substitution patterns in molecules. We look at the number of carbons bound to carbon, and we look at parent chains and substituents. So looking at this as an example, we first of all find our parent chain. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 9 carbon long chain, and so this is the parent chain. These other 3 things are substituents coming off. And so we say, well, if it's in the parent chain and it's bound to one other, this carbon is bound to one other carbon, then this carbon is going to be primary. This carbon is going to be secondary because it's bound to 1, 2 carbons. So that's a secondary. So this is primary, secondary. Looking at this carbon, it's in the parent chain, and we say it's bound to 1, 2, 3. So that's a tertiary. Looking at a quaternary example, we have this one. This carbon is in the parent chain, and it is bound to 1, 2, 3, 4 other carbons. So that is quaternary. Looking at some of the substituents here, on this carbon, for example, because it's in a substituent carbon, we say it's bound to 1, 2, 3 carbons. When that's the case, it is considered secondary. In the secondary, we kind of pretend like we cut it off from the parent chain, and we say how many is it bound to? It's bound to 2. So that's kind of how we look at that to determine it. The same thing goes for this carbon here. We say, let's pretend like we cut it off for a second. It is bound to 4 carbons, and so it's a tertiary. But to see where the tertiary comes from, we cut it off. And we say, how many is this carbon bound to now? It's bound to 1, 2, 3 other carbons. And so it becomes a tertiary carbon. Right here we have an example of a carbon that has no other bonds to carbon. That is considered a methyl group, and that's what we have, is a methanol. And that's more or less how substitution naming goes. It's pretty straightforward. Sometimes it takes a little practice, but that's the idea. Okay, so continuing on with a little bit of carbon substitution and how some of the common name substituents, where they come from. Let's look at this side chain here. So from our previous board that I erased, we see that this is bound to 3, but because it's a substituent, we can pretend like it's cut off from that parent chain. When we do that, we see that, and I will make this one longer, we see that this has 2 carbons bound to it. And so it's 4 total long. So we know that it's going to be a butyl of some kind, but what kind of butyl is it? Well, the carbon bound to the parent chain is a secondary carbon, because we said that it was secondary. So it is a sec-butyl, and that's why it has that name. If we were to take one of these carbons and put it on that same carbon there, once again, we pretend like it's been cut off, and so we look at the substituent and we say, what is the substitution on it? And it is a 1, 2, 3, and it's 4 carbons, so it's a butyl. So we just take tertiary and we cut off the end part, so tert, butyl. And the same thing goes for the sec-butyl. It's secondary, so we just cut off the end, and it's sec-butyl. So sec-butyl, tert-butyl. And other examples can be figured out the same kind of way.